Hi, welcome back. So we're in chapter 2, story of math at the outlined area of mathematics. In this outline, we're going to cover a number of sub-outlines that fundamentally help us to understand how we can efficiently use mathematics as an independent language. First, we're going to start with the number system. As we have explained in the previous section, that number system actually is the essential seed where we translate every motion into a certain numbers, and from there we start to put it in a form of equations, and from there we build up. So it's perhaps a good idea to try to categorize this number system into a certain categories. First, we're going to start with the natural numbers, which denoted by letter N. And basically the natural numbers comprises first with a 0, which indicate a null value, then 1, which indicate the whole unit of something, and then we have the prime numbers, and the prime numbers are the outcome of a product where multiplied the number by 1 or 1 by the number itself. And then we've got the composite numbers, product of two smaller numbers multiplied as the output of this number. And then we've got the integer numbers denoted by letter Z, and the integer numbers can contain all the natural numbers, and in addition to that it contain also something called the negative integers, and basically it is the inverse of the natural number. And then we've got the rational numbers denoted by letter Q, and the rational numbers contain all the integer numbers and contain something called a fraction. Basically the rational numbers are the ratio between two numbers, so x over y. This is the form of any rational numbers. So for example, when we have a certain circle like that, we have 4 parts that all of them indicate the whole unit of 1. That is the number of y. And then if we shadow, for example, 2 of them, that indicate number x. That's why y cannot be 0. Now, perhaps maybe you can think of the fraction also as a subcategory that contain the finite decimal. And what we mean with finite decimal, that means the number after the separator will be finite or determined. For example, having the value of 3 over 4, we know the value should be 0.75 only, and then we stop out here. That's why it's a finite. And then we have the opposite of it, to have a repeating decimal. For example, 1 over 3, a repetitive form of a 333. And then also maybe you have the dyadic format, where every y value, it's the power of 2. So all the values, for example, 3 over 4, or maybe 4 over 16. And then we have the real number denoted by letter R, that contain all the rational number and also the irrational number. And basically the irrational numbers are numbers that can't be expressed as a ratio of 2 integers. Some of those famous irrational numbers, like the pi value, the e natural logarithm. And then finally we've got the complex number denoted by letter C, that contain all the real number in addition to that, to the imaginary number. And the imaginary number actually is known as the square root of minus 1, or denoted by letter I. Now basically this is the entire system of numeric categorization of numbers. So this work happened, or this system evolved and developed over many years of a human existence. Next, perhaps we're going to take one step further by starting to discuss the geometry subtitle. That's exactly what we're going to do next. I'll see you then.